Okay, hi linear algebra, just picking up from where we left off in class. This was the traffic flow question, number 1. I just duplicated here the systems. Here's Oliver's augmented. Here was the solution from the row reduction tool that I did send you all a link for. Here is this solution written as an equation. I noticed that from these 3 equations, x of 4 is the free variable, so let x of 4 be the parameter t, in which case, okay, these 3 equations here become these 3 equations, all right? And if t equals 100, or if x of 4 is 100, the roadway x of 1 has 1100 cars, x of 2 has negative 100 cars, and x of 3 has 500 cars. When x of 4 has 100 cars. I made a little note here in red. This is interesting. What this means is that if there are 100 cars on roadway x of 4, there are no cars on roadway x of 2. And that naturally, I made a note, it naturally raises some questions about optimal traffic flow, So, I could ask you this question, when x of 4 equals 100, is this street system, or is this grid street system being used optimally? I mean, could the case be made that somehow the number of cars on these other side streets, including x of 4, could be diminished by utilizing x of 2. So there is an interesting question about optimal use. So, I would argue in this situation, again, with many simplifying assumptions that have been made, that when there are 100 cars on x of 4, given the inputs to the nodes that we were given, that is not an optimal choice for x of 4, because you are overwhelming or overloading 3 streets at the expense of closing 1. Okay, it's just an interesting question. Okay, so this is the question that I think it was Oliver too. Yeah, Oliver. You had, if we want to ensure that traffic flow is non-negative, what did we do? Well, that means, what I did here, Oliver, do you see that? That means we want x1, x2, and x3, which are these 3 expressions, to be non-negative, bigger than or equal to 0. And just solving these 3 inequalities for t, okay, we see that for all the roadways to at least be non-negative, t must be less than or equal to 0, and greater than or equal to 200, and less than or equal to 600. And you can see that in order to ensure that all 3 conditions are met, the constraining restriction on that free variable t, or x of 4, is such that the number of cars on roadway x of 4 be between 200 and 600 cars, which actually, interestingly, kind of reinforces the point above, that by inspection here, x of 4 being 100 does not seem to be an optimal use of roadways. Okay, so enjoy the light homework night tonight. It's going to be quite light. I'm looking at these traffic circles, and I think what I want to do here is give you, I only gave you 4 questions. That's ridiculous. Okay, I'm going to give you 1 question from the handout. So handout number 4. Look at that. And don't forget, you can also use that row reduction tool. Handout number 4, and then in your textbook, please do number 2 on page 94. Okay, it's just 2 questions, that's it. And this should be a very light linear algebra day, because I do see you tomorrow. It's very light. Like I said, we only did the JV application. And I'll see you tomorrow. And then we have our long period coming up soon. That'll be really fun. I've got a pretty fun idea planned for our long period. Okay, have a great evening. Good night.